In this video, we'll continue our discussion of 11.1. This is standard unit vectors. This is foundational, actually, for the rest of the course when it comes to vectors. The unit vectors 1, 0 and 0, 1 are called standard unit vectors. How we define these is we just call 1, 0, I. And how we write this, because we can't do bold, just do that. The vector 0, 1, that's the y direction, I, j, right? J is written like this with their units, has a length of 1. Notice that this, if I were to put this on a graph, that first one goes over like that. The other one, 0, 1, goes up like that. They both have lengths of 1, right? And 1 is on the x-axis, so all the i's represent our x components. J's represent our y components. Right, we can use this. Okay, let's follow this long line of reasoning. I got some v, that's a vector. Here's the definition of that vector, components, v1 and v2. Well, take a look. I can split it like this because if I put them back together, I would just add v1 plus 0 and 0 plus v2 and it'd get me back. But now I can take maybe this line here and factor out a v1. I can take the second one here and factor out a v2. And then that leaves me with v1i, v2i. So to go from one to the other, so let me give you let's look at example down there. Actually, let's finish those definitions right here. The vector here is called the linear combination of I and j. Okay, linear combination will be anything of two things being multiplied by those two things added together. The scalars v1, 2 are the horizontal and vertical components, right? We already knew this. v1 is the x component. That is my horizontal. v2 is my y. Same thing in this definition. All we do instead of using the components in the brackets, we use I and j. All right, so let's start off with u. So let u be the vector with the initial point 2, -5, and terminal point -1, 3, and let v be -2i minus 3j. Right, each vector is a linear combination of I and j. Okay, so a down here is just u. Well, first I'm going to do it in component form and use my subtraction. -1 minus 2, that's my x components. The y's are 3 minus a -5. So this vector is equal to -3, 8. Okay, they want us to write, it says write each vector as a linear combination of I and j. So u is equal to -3i plus 8j. That's it. That's all they want. It's just another way to write it. It's going to allow us a little later to do more algebraic and calculus on these type of things. So both notations are important. We need to know both. Okay, so W, first thing I'm going to do, they define W. I am going to write it out in component form and work it out and then put it in IJK form. So there's U minus 3, and I'm going to change V to component form, -2, -3. And I'm going to work this out. All right, so I got -6, 16, plus 6, 9. If I add those together, I got 0 and 25. So writing W as a linear combination, I'd have 0i plus 25j, or we could just say 25j. If it's missing, we know it's 0. All right, so that is the standard unit vector form. We're going to do one more example in this video, working with an angle instead of a direction. So let's give that a shot. So here's example 6. The vector v has a magnitude of 3. Okay, I'm going to write this down. Magnitude of v is equal to 3, and it makes an angle of 30 degrees. So let's just stick with degrees for a moment. With the positive x-axis, okay, so write v as a linear combination of the unit vectors I and j. Okay, so I'm going to show you how to go about this. We have our vector, and all I know is this vector has a length of 3 and an angle of 30 degrees. This is going to be your favorite topic, trig. Here we go. We have a triangle. It's a right triangle. We can create from that. And we want to come up, we want the x component, we'll call this v1, and call the y component v2. And we're going to use some trig to get to that. All right, so the cosine of 30 degrees is v1 over 3. All right, that means v1 is equal to 3 times cosine of 30 degrees. Cosine of 30 degrees is radical 3 over 2. So I got 3 radical 3 over 2. All right, so there's that one. I'm going to move this over. All right, now I can do the other one. I got sine of 30 degrees, and that's equal to v2 over 3. That means v2 is equal to 3 times sine 30. Sine of 30 is 1/2, so v2 is 3 over 2. And they want us to write v as a linear combination of the unit vectors I and j. So the vector v is equal to 3 radical 3 over 2i plus 3 over 2j. So trig is very important. We're going to use actually quite a bit of trig dealing with these vectors and where we're going in the next couple sections.